I'll probably start with the introduction and then.
Okay, recording has started.
All right, thank you.
All right.
Hello and good day, everyone. I'm Ujjwal Gadaraju, an assistant professor at the Web Information Systems Group, and this is at the faculty of EMCS. I also happen to be a co-director of the Design at Scale Delft AI Lab. It's my pleasure to welcome you all to the third edition of the Academic Fringe Festival. And this third edition is on designing at scale with human AI collaboration. As we discussed last week, we can harness unprecedented amounts of data using AI today, and we can create opportunities to tackle all kinds of interesting and important societal problems across a plethora of domains like health and well-being, as well as mobility. And to make AI useful, we need to find new ways to combine the creative power of humans with the analytical capabilities of machines. While designing solutions and developing systems for social good, a key challenge lies in finding out how to help designers, experts, and societal stakeholders in working together with AI to prepare, realize, and evaluate design interventions. How can we reduce design complexity for large-scale social interventions? Through the course of this edition of the Academic Fringe Festival, we'll discuss these interesting breeds of challenges. Some of you were there last week, and we kicked this off with Ben Schneiderman, and we had an excellent discussion around human-centered AI. This week, I'm thrilled to introduce our next speaker in the series, Chenhao Tan, who I've had the pleasure of meeting several years ago in the grand company of some Nobel laureates and Turing Award winners at the Heidelberg Laureate Forum, where we were merely PhD students and still finding our path along our research careers. But I'm very excited to see where Chenhao has gone already and the kind of amazing things he's been up to. Chenhao Tan is an assistant professor of computer science at the University of Chicago and is affiliated with the Harris School of Public Policy. He obtained his PhD in the Department of Computer Science at Cornell and did some amazing work while he was there. And he also has bachelor's degrees in computer science and economics from Tsinghua University. Prior to joining University of Chicago, he was an assistant professor at the University of Colorado in Boulder, also did a postdoc at University of Washington. So he's had a nice, rich, colored past. And his research interests of late include the field of NLP. They also lie in human-centered AI. And he has also been dabbling in computational social science. And I've been following his work from a distance, and I'm extremely thrilled to have you here with us, Chenhao. Without painting more strokes about the laurels and awards which Chenhao has certainly accumulated over the last few years, I'll just turn this over to you, Chenhao, while he tries to give us another nice peek into some of his work in human-centered AI and tell us more about complementing humans with AI. Over to you, Chenhao.
Thank you so much for the very nice introduction and organizing the entire talk series. I think is a very nice set of talks that I'm personally looking forward to. I guess in this talk, I prepared it for about 30 minutes, so there will be more time for discussion. And it would be nice. And I'm also very welcome questions throughout the talk as well. Feel free to interrupt me anytime. And I'm happy not to go through the entire talk either. And I think a lot of this will be on a more constrained setting compared to the great promise of human AI collaboration that was put out earlier. So here, mostly we are going to think about a kind of decision-making setting. And also, I guess on this note, I would appreciate if you can turn on your video so that I can see a couple more faces and also kind of make some friends through this talk. Okay, cool. With that, I'm going to get started. So today's talk, I'm going to kind of mostly talking about how we can complement humans with AI in somewhat constrained setting. Maybe you make a decision, or to even think about making a prediction given an instance. So we have seen a lot of kind of impressive advances in AI. For instance, two examples: AlphaGo, and the other one is radiology tasks broadly, or in this case, a particular title is about breast cancer. And sometimes we can see this from big titles about AI outperform humans, but I think that claim usually requires a little more thinking into it. But broadly, I think all of us will agree that AI holds promise for improving our society in a wide range of domains, ranging from medical diagnosis to education to justice systems and almost every aspect of our society. And however, a black box can come up with many issues. For instance, many of us have seen issues around bias, ethics, and safety. If AI is just left on its own. And so a lot of my work is about thinking about like how we can improve AI through explanations. And ideally, if we have explanations that can allow us to open the black box of AI, then that can enable better human-AI interaction. As a result, it can improve both people and improve AI. And in particular, mostly I'm going to think about this setup in this seminar paper by Dosh Velez and Kim on this notion of different level of evaluations. And in the end, I think the final evaluation that I think is most valuable is this kind of application grounded evaluation, where we have humans actually making the decisions and see whether the explanations or AI model can improve human decision outcome. And just quote them, specifically, we evaluate the quality of explanation in the context of its end task, such as whether it results in better identification of errors, new facts, or less discrimination. So like in general, in this talk, I'm kind of going to focus on this particular way of thinking about evaluation of explanations. And I do think is, in the end, the most important way for us to realize the outcome of human-AI collaboration. And ideally, in this task, we would want to see that sometimes it's referred to as complementary performance. In this outcome, human and AI team together, we will see an outcome that this team is better than either human alone or AI alone. But in practice, usually complementary performance is actually quite elusive. In a lot of cases, in this kind of decision-making setting that I'm talking about, is useful to constrain that. I think most of the claims here are about the decision-making setting I'm going to talk about in this talk, and I will kind of give one concrete example very soon. And there's a long list of papers that generally have found that a lot of times what we see is that AI is better than human plus AI than better than human. So introducing AI assistance indeed can improve human performance, but it doesn't, is not sufficient to bring the human plus AI team to be better than AI alone. And one concrete example in our own work is this task called deception detection. And this work was joined with my student, Vivian Lai. And the task is deceptive review detection. So roughly you are given a text and your job is to decide, or the task is to decide whether this review is written by someone who have never been to the hotel or someone who actually stayed at the hotel. And in particular, let's see whether we can have some interactive event. If you are familiar with the Zoom function about raise hand, maybe like after I read this review, I'll try to use raise hand for like a small interactive activity. So this review says, my stay at the Talbot was a wonderful experience. The service at this upscale hotel was beyond my expectations. The Gold Coast location is close to Michigan Avenue, the museums, and many of the other sites Chicago has to offer. If you are visiting Chicago, I highly recommend the Talbot. If you think this review was written by someone who has never stayed at the hotel, raise your hand.
I don't have the ability to raise hand as a host, but count mine as up.
Okay. Anyone else? Good. So if you think this one was written by someone who actually stayed at the hotel, raise your hand.
Just to provide a voice for the other side, let me put my hand up as well.
Cool. Yeah, I guess in this big sample that we have like two people who think it's genuine and one person think it's deceptive. And in fact, this is actually deceptive review. But the point of this is that this is actually a very hard task. And out of our small sample, 2 out of 3 humans got it wrong. And in practice, I think people's performance is about chance, as we will see later. And what we did in this work is kind of have proposed this spectrum of possible ways that AI can assist this decision-making task. Like, to be clear, it's a very simple task. It's essentially a classification task. I give you a piece of text, and your task is to provide a binary reading outcome. And I'm not going to go into details of these different systems. If you're interested, you can check out the work, and also you can play with it by going to this link. But in general, as I said, in this setup, what we have seen is that AI assistants can improve human performance. So if you look at a control, which is the human performance in this task, is essentially about a chance. And then by adding different types of AI assistants, we are able to improve human performance to various degrees. And there are more subtly here if we think of issues around accountability or human agency, is more complicated. But for now, I think it's fine to just take it as good news that like AI assistance does improve human performance pretty substantially. However, if we look at human performance, AI performance alone, then we see that human plus AI is not as good as AI. And in general, I phrase that as kind of a big challenge, at least in this space of human AI decision making. We recently have a survey on this topic. If you're interested, I would also recommend checking out the survey. There are a lot more nuance in how the task is set up and how people have been designing these experiments. But in this talk, I'm kind of going to try to kind of give a high-level view of what I think is happening about the lack of complementary performance in human AI collaboration for this kind of decision-making task. And in this particular task that I have shown, like in the task, so we generally, I think it's useful to group this into three sections. First, in the task, deception, review, detection, for instance, humans may have very limited intuitions in this task. So this is known to be a very hard task, and maybe they just have a little to offer. And second, in terms of AI assistance, what we have been giving in this, for instance, are kind of highlighting some words in the review or giving you the pretty label. And these are all fairly static, and also they are just giving you without too much context. So this kind of real-time static explanations may not be sufficient in these kind of tasks where humans do not have a lot of intuition about, or humans are not naturally good at. And we will refer to this kind of task as discovery tasks in general. And finally, in experimental design, there's a lot of kind of issues. There are kind of issues that we recently realized is that this kind of setup that we typically adopt are based on standard machine learning setup. So we will split the data set randomly into train test and test set, and then use a test set to evaluate both AI performance and human plus AI performance. And as a result, these examples are essentially in distribution for the AI, and it leaves little room for human strength to kick in. And so to kind of I think in order to achieve complementary performance, an important open problem was the best way to integrate human strength and AI strength. And sometimes it also means that like what exactly is human strength, and this aligns very well with which was introduction earlier. And we have done some work in each of this category. And in the interest of time, I'm going to kind of focus on two projects quickly in this talk. And both of these projects are from the issue of scale. And the general kind of intuition is that AI can deal with scale better, which is something we have seen a lot of success about. For instance, like arguably search has achieved phenomenal success. All of us has easy access to a huge web just through Google or Bing or DuckDuckGo, in case like you prefer some of this third-party or not third-party, non-advertising based companies. And we are going to start with the first part is on decision-focused summarization, and this part will be more algorithmic, and the second part will be more human-computer interaction oriented. So in the first one, the scale issue or the efficiency issue that I'm talking about is the fact that a lot of humans, when they make decisions, it requires making sense of large amount of information. For instance, imagine a doctor, in order to make a diagnosis for a patient, they may need to go through a large collection of notes. And summarization or AI can play the role of reducing this huge amount of text into a much more succinct version. And in this case, we call it a summary. And human AI collaboration can happen in this fashion. Well, if we assume that humans can make good decisions based on the information, necessary information, then by providing the summary to humans can supposedly make a better decision by essentially navigating through this large collection of text that human alone cannot really go through. And this would be one way to shape human AI collaboration. And just to kind of emphasize, AI's role is to reduce this collection of this large collection of text into a short summary, and a human's role is to make a decision based on this summary. And to make this more concrete, imagine a doctor make a diagnosis for heart disease. And one argument that we're making this work is that typical summarization methods do not account for targeted decision. So given a collection of text, if you give this to a summarization algorithm, it will just general summary without knowing that the doctor is trying to make a diagnosis for heart disease. And as a result, if you are lucky, this summary will contain some information about the heart disease or about the person's heart condition. But at the same time, you may also include some conditions, for instance, like the person had a foot injury a year ago, which is hardly relevant. And another way to think about this, like I got a feedback that sometimes your foot injury can be related to hearts. Knowing that that can be the case, but the kind of the main point is that this general summary doesn't even change no matter what decision you are making. And if you are making some diagnosis about pancreatic, it will still look exactly like this. And as a result, this may not be the best way to help people make decisions. And what we are proposing is that we need to kind of generate these summaries that are decision focused, so that all these texts are relevant to the final decision. And as a result, humans can make better decisions given this kind of decision focused summaries. And this part of the talk will be thinking about how we can generate this kind of decision focused summaries and what is required to generate decision focused summaries. To get into a little more formal description, so the task is given input text, and we are going to think of them as basic. We are using sentences as basic units. So we have capital S number of sentences, and our task is to select a subset of these sentences. So if you are familiar with NLP, these are essentially extractive summarization. And our goal is to support making the decision. And ideally, we would like to try this out with doctors or like people who actually make decisions given a big collection of texts. And in this particular work, we use a proxy through web reviews. This may be somewhat is slightly different from what your typical restaurant review experience, but I think it's actually closer to the investment experience. So the idea is that we are given the first 10 reviews. So we get some history about how well this restaurant is doing. And then your task is to determine how well the restaurant is going to do in the future. So after 50 reviews, what the rating will be. And is very similar kind of to projecting how well a company is going to do in the future. But we choose reviews so that most crowd workers will have more experience and it doesn't require specific expertise. And then the decision for summarization will choose sentences from these reviews that hopefully give you a good sense of how well the restaurant is going to do in the future. And our general strategy is to kind of deviate from typical summarization setup. We are going to also have future reading for this training set. And as a result, we'll build a supervised model that predicts future reading of a restaurant given a collection given the first 10 reviews. And then we are going to propose an algorithm that are going to achieve like objective components that lead to a good decision for summary based on our hypothesis. The three criteria are decision for faithfulness, decision representativeness, and textual non-redundancy. And I'm going to go through each of them to give more intuition about what we think makes a good decision for summary. So decision faithfulness essentially says that given the summary, if we give this to the supervised model that we have, it should give the same decision as the model using the full text. So at least from the model's view, this selected sentences provide similar information compared to all the reviews. And that's why we call it faithfulness. And in concretely, we use this log absolute difference to operationalize this faithfulness theorem. And then decision representativeness is something that's newer, and I think is kind of interesting within this special context. So we would like to the selected sentences to also represent the overall distribution of individual sentences. So imagine we have 10 reviews, so we'll have a collection of texts, and each of this sentence will generate a predicted score, and that becomes the distribution we visualize on the right. And ideally, the selected sentences should cover different parts of the distribution and give you a sense of the overall distribution. And you can see our algorithm compared to some other baselines we will explain more later seem to cover the distribution better. And for instance, these green stars tend to focus on the right rather than covering the entire distribution. And to operationalize it, we use this Wasserstein distance to define how representative the chosen sentences are. And finally, textual non-redundancy essentially means that we are trying to increase the diversity of the sentences, and this is relatively standard in summarization, so I'm not going to kind of cover this in detail. Roughly, kind of another way to think about this is that in addition to typical summarization, we added 2 components that are related to decision making, and hopefully this leads to better summarization for people, better summaries for people. And this kind of brings us to our kind of final objective function, and we propose a greedy algorithm to iteratively select the sentences to maximize this objective. And to compare, to evaluate our method, we compare this to standard summarization method, such as BART, Prism, and random selection, which in this case is actually a pretty good outcome because random entails some kind of representativeness because like you are just taking random sample from this overall sentences. And we also compare this with an explanation method. We choose 2 typical ones. I'm not going to kind of explain in detail, but I think these are kind of standard explanation methods people use to explain a model. And well, I'm going to start with automatic evaluation. And I think the kind of human evaluation will be more interesting. But I think this automatic evaluation also shows you like how different existing summarization or explanation methods are from our proposed method. So here, this is to evaluate decision faithfulness. So this column that I'm highlighting is about the mean squared error with using the prediction from using the full text. And these are the text-only summarization-based methods. So you can see all of them have around 0.3, and random is actually better than BART, which is kind of state-of-art abstract generation method. And compared to model-based explanations, model explanation methods are actually worse in terms of decision faithfulness compared to this text summarization method. And like randomism, in fact, is actually better than IG, integrated gradients and attention as a way to explain the model when we evaluate decision faithfulness. And if you use our method, you can see like it's actually like almost in a different scale. If we use all of our components, we almost get a complete faithfulness. Our selected sentences will always give the same prediction as the full model. And even if we turn off our components that's dedicated to decision faithfulness, we are also getting better outcomes compared to all other baselines. This says that decision representativeness can also kind of capture a good deal of what the final decision that the model is making. I'm going to skip this slide and just focus on the human evaluation. So in order to kind of understand how well humans can do in this task, we simplify this task a little bit because we think it will be very hard for people to do the regression task of deciding whether the restaurant is going to get 4.4 or instead of 4.5. Instead, we are going to make this a relative comparison problem. We give you first 10 reviews of 2 restaurants, and we make sure these 2 restaurants have exactly the same average rating within the first 10 reviews. And then we use the same summarization method to generate 2 summaries. So we don't show you the actual 10 reviews since that would be too hard to read. We show you 2 generated summaries and then ask you which of the restaurant will be rated better after 50 reviews. And we consider summarization algorithm better if it can better support people in making these decisions. To make this concrete, I'm going to show you 2 set of summaries for 2 restaurants. The first one is IHOP on the left, and the second one is Tasty Kebab on the right. I'll let you, I think we have time, so I'll let you take a second and look at these 2 reviews, and maybe if you can use the reactions. Okay, I'll just ask later. Maybe I'll like just take 30-minute pause and 30-second pause, and then ask for your preference on which restaurant is going to do better in 50 reviews. Now raise your hand if you think IHOP will have better ratings in 50 reviews. I think I saw 2 hands. Oh, okay, this is much better. We got like 5. We got a lot more hands this time. I think I saw 2 hands on video and 4 hands on Zoom, so that's great. Okay, maybe there's some overlap. Now I just saw 4 hands for IHOP. What about Tasty Kebab? If you think Tasty Kebab is going to do better in 50 reviews, raise your hand. We got 2. We got 1. Great. So I guess I will review the answer in a couple of slides, but I guess in this case, Tasty Kebab was actually the winner. But like this is not real about you. So your job is to make a decision about a summary. So this is more for evaluation of the summarization methods. And in general, like this task is very challenging for humans. And as a result, most of the human performance actually hover around 50%. And in fact, if we use summarization method, Prism is a text-only summarization, IG would be a representative case of a model explanation-based methods. Both of them will actually lead to performance slightly lower than 50%. Because like this is essentially like the baseline is always 50%. And the random is actually slightly better than those. And our method is the only one that allows humans to outperform random, or outperform 50% reliably. And just to be clear, like this task ends up being very challenging to humans, so we still didn't achieve human plus AI in this one. Hopefully, I will show some better news in the next work. But however, like in terms of good, like if we look at individual differences in this work, 3 participants were actually able to achieve 90% accuracy with our method. So that's kind of quite encouraging, while like none of the participants using other methods were able to like achieve over 90%. And if we go back to the summaries, these are the 2 restaurants I asked you, and Tasty Kebab was rated better after 50 reviews. And I cheated here. I show you the summaries from Prism, which is not the best thing you can do. But that is to highlight that using our method, if we use Prism, it all shows these very positive sentences about IHOP. And it kind of makes sense if you look at the individual predicted scores in the green stars. So most of you, as a result, believe that this restaurant is going to do better. But in fact, this restaurant also gets some pretty bad reviews, and our method is able to pick one of them so that it gives you a much more representative distribution of the reviews of this restaurant. And in particular, this sentence says, "My soup came out cold. Our server forgot our drinks, and they just microwaved to warm it up, and it literally overcooked everything in the soup." So given our summaries, the participants on average do much better compared to Prism. In summary, I show you a new formulation of summarization, and we call it decision-focused summarization. And our method is able to outperform text-only summarization and model-based explanations, both in automatic evaluation and human evaluation. And I think although we are not achieving complementary performance in this task yet, I think there are many future applications. If we can team up with domain experts, this can potentially lead to some kind of nice outcome. I'll take a pause in case there are any questions. Cool. Then I'll move on to the second part. This is some kind of very new work that I have never presented before. It's called human collaboration while conditional delegation, a case study of content moderation. And this joint work with Vivian Lai, Samuel Cadden, Rajat, Vera, and Yunfeng. I'm sorry, I forgot a picture of Vivian on this slide. That was a genuine mistake. So in this decision making and this decision focused summarization talk that I was to give, and in a lot of prior work by other people, generally people are focused on AI systems for individual decisions. For instance, like in medical diagnosis, we give you a patient and then ask you to make a decision. But in practice, like there are a lot of problems that are really suffering from the scaling issue. For instance, on Reddit, there are about 303 million posts made in 2020, and every day there are just so many comments that are posted, and it requires moderators to make sure that most of these comments are complying to the rules of each individual subreddit. And as a result, it will be very helpful if we can help them deal with this huge scale of comments. And in this case, it's actually okay to have some form of automation instead of completely human plus AI collaborating on every single decision. And if you look at the current setting, it actually already includes some automation. For instance, like we can use a manual rule-based approach where we create rules manually, and these are generally keyword-based rules. And then based on these keyword-based rules, when we deploy the system, if a new comment matches this keyword-based rules, we're going to take some action. If there's no match, we're not going to take any action. And as a result, if you have the word, for instance, I guess I'm not going to pronounce it, but I intentionally kind of hide them. But imagine some of these words would highlight some genuinely toxic comments. But on the other side, they may also match some non-toxic comments. And that as a result, these keyword rules are generally not very precise in terms of how well it can match toxic comments or rule violating comments in general. And what we propose is to think about how we can have a human and AI to work together, and we refer to this paradigm as conditional delegation. And in this case, first, we are going to have a human and AI to identify a trustworthy region, and this region would be regions where humans have looked at the outcome of AI, and generally humans that think AI is doing well in this region. That's another way to think about it. And then when we during deployment, when we give an instance, we are going to pass that instance to check this to check whether it's in the trustworthy region. And if yes, we are going to allow AI to make predictions on these inputs, and only take actions on the AI predicted based on the AI predictions. And then for the comments, the instances that are outside of trustworthy regions, we can take other actions if this can be manual review or go through another model that's more complicated and so on. The important thing is when the instances are in the trustworthy version, it will go through this AI model, and we will make decisions based on AI predicted outcomes. So to make this very concrete in the context of moderation, we can show you kind of the interface that we ask people to do. So we start with a manual condition. Essentially, you mostly have a search interface. You can search comments and see what the comments look like, and then add a rule. And the rule is a way for us to indicate trustworthy regions, and we define rules based on keywords in this. And potentially one can support a more complicated way to make rules. And in this manual condition, all the comments that match this rule will be considered toxic and be given, for instance, to moderators to decide whether they should be deleted. And in conditional delegation, it's important to highlight the role of the AI. Once we identify these roles, we don't give all the comments that match these roles to AI, to moderators. Instead, we'll only look at these comments that are predicted toxic by AI model. So for instance, like just to use a hypothetical example, in fact, this was a good rule in our data set. You can use the word you as a rule. And if you think that the AI is going to do well in all the comments with the word you. And then when we actively make decisions, the AI can give you all the comments that contain you and are predicted toxic. And it will ignore all the comments that are predicted non-toxic but contain the word you. And as a result, you can use the AI to filter only the ones that are relevant for your decision making, and as a result, kind of help you deal with a large scale of number of comments. And this is another condition in this conditional delegation paradigm where we only give you the predicted label. So it's very similar to the random, the manual interface. But in this case, we will see the predicted label and decide whether a rule is worth adding to your final decision making trustworthy region pool. And we also give explanations by highlighting what words the AI model used in making these decisions. And this may help you make better rules. And then in the global version, we also give you this list of words that the AI heavily relies on in making these decisions. And potentially, this can help you make rules faster, and also kind of give you some idea of what are possible words to be used as rules. And before we show you the results, let's kind of go through the measures. We consider two types of success. First, we are going to look at precision. So we look at whether the trustworthy regions are actually trustworthy, and whether the AI predicted toxic comments are actually toxic among for the comments that match the rules that people make. And we also have another measure that's more useful for the notion of recall. Instead of like using recall, since like it's not necessarily important to catch all the toxic comments, it's important to catch as many as possible to align with the current goals of moderators. So we look at the number of reported toxic comments minus the number of reported non-toxic comments. And this measures both precision and coverage. And this kind of, if we think the utility of one matched comments is the same as the utility of one match, the penalty of one matched non-toxic comments, then this is one way to think about the utility function for moderators. And finally, we also look at efficiency, the number of rules per minute that our participants were able to make, and also the number of actions that they engage with our interface. And I think efficiency is a little more better defined, but engagement also kind of tells you how useful our interfaces or our tools are for this particular task. And finally, we're going to look at the user study results. So it turns out that in this setup, in this task, humans are actually able to create these rules with very high precision. I mentioned the in distribution and out of distribution difference earlier. In this work, we also experimented with out of distribution. The story is slightly different for out of distribution. In general, it's harder, and I would recommend you to check out that work. But in this, check out the paper. In this talk, I'm going to focus on the in distribution setting. Well, the test set is the same as the training set. And in this case, you can still see that even the AI alone, the decision would be 0.84. And if we only ask a human to make rules with a manual approach, human can only get a precision of around 0.8. But with our model assistants, the precision are all much better than these two. And you may think this is because of low coverage. So we also look at rewards. And in rewards, we don't compare with AI alone, since AI just compare with kind of matches everything. But if we compare with manual, the rewards of our approaches, conditional dedication almost doubled if we only make manual rules. And in short, I think this is a case where like it seems that we are able to achieve some kind of complementary performance. Human plus AI are able to outperform either human alone or AI alone. And if we look at efficiency, although as you have seen earlier, all these three methods with conditional delegation, they perform roughly similar in terms of rewards and precision. Maybe like global explanations is a little better in reward. But in terms of efficiency, rules per minute, explanations are very useful in improving the efficiency. And in the manual condition, people are actually very fast compared to predicted label, because I guess in predicted label, people are seeing this more information and they need to reason about AI, which they didn't need to do with the manual condition. And in one way to kind of break down this efficiency or the observational efficiency is look at this overlap with the most frequent words or the global explanations. And one reason that people were much more efficient with global explanations is that people tend to use more words from the words that provided as hints, and as a result, that can speed up their process. And conditional delegation also leads to much higher engagement. People play with the interface a lot more than the manual condition. And as I said, kind of this allows people to think about their rules more, and it indeed leads to better rules. And with explanations, the engagement is a little lower than with only predicted label, kind of because explanations give the way for people to make more efficient judgment about what the AI is doing. And in summary, I think in general, kind of the big question in this line of work is to think about like how can we allow people to effectively use these kind of imperfect models. And we saw that conditional delegation gives a kind of promising alternative paradigm that allows user to control when to trust or distrust AI without kind of making individualized decisions. And as a result, it can lead to potentially lead to complementary performance. With that, I think I was just to kind of end on this kind of general question that personally I'm still thinking about, like what is the best way to combine human strength and AI strength, and what exactly are AI strengths and human strengths. And with that, thank you, and I'm happy to take questions.
Awesome. Thanks a lot, Chenhao. That was a very thought-provoking talk, and thanks for shedding light on some of your most recent work. While we wait for questions to float in, let me just remind all the audience members that you can unmute yourselves if you have a question, or feel free to type it out in chat. I'll be happy to relay your questions. Maybe want to just get this process going, Chenhao. One of the things I was wondering about when you spoke earlier on about the first piece of work where you were exploring how you can account for target decisions, and you came up with this decision-based or decision-focused summarization method. I was wondering how the human plus AI, notion that you were trying to put across would sort of change if you were to look at all the human factors that shape up the whole human plus AI notion, which came through again in the second half of your talk where you spoke about conditional delegation. But to what extent do we constantly have to keep thinking about these human factors of how we end up trusting a model or relying on it on an instance level, right?
Yeah.
Could you share some thoughts through your work on that space?
These are great questions. Actually, I think that's a very nice observation. I'm like very impressed. I think I kind of skipped that work in general, like in the very quick example on deceptive review detection. I think that one, a lot of thinking around there is about how a kind of human AI trust along on individual instances. And I think that is very important line of work and critical for the use of AI. I personally end up as you can see in the trajectory, I deviate a little bit from that paradigm. Partly because I think I'm trying to kind of complement the humans is to echo the title, this talk in the end is about complementary AI, humans with AI. And in a way, while the trust on individualized instances can be very important, there's a lot of work about maybe showing explanations will allow people will change how people trust AI, and may sometimes mislead AI in over trusting in some cases and under trusting in some cases. But if our goal is mainly about performance, maybe like trust at individualized level may not be the most important problem. That is kind of the trajectory in this line of work that I'm presenting. So in this decision focused summarization, kind of like is about another way thinking about like is kind of like decomposing the task, a little similar to earlier work on crowdsourcing. And in the first decision focused summarization, where we decompose into summarization and make decisions. And there, I think it's possible that AI can be built to mislead people if we have to think that way. But on the other hand, similar to search or similar to kind of the reality is that a human cannot really go through everything. And one future project we are working on, we are thinking about is to make the process interactive. Like we don't have to just rely on this some static summary that AI presents, and we can potentially use AI to interactively explore the corpus and identify the most useful sentences. But ultimately, this is a way for you to make sense of this large collection of text that you couldn't have done before. And I think that would be a kind of nice way to somehow sidestep the trust issue a little bit. Is kind of help you dealing with the scale. And the second one is still dealing with the issue of trust, but now it moves the trust to this behavioral question on, like in the end, there will still be this human plus AI or human make individual decision problem, but because we expect moderators to be able to make individual decisions on their own anyway, so AI assistants on these local decisions are not as important. And their main pain point or their main challenge is about the scale of comments. And this conditional delegation allows them to decide when to trust AI in terms of the collection out of the pool level or the population level, and use that to use AI kind of as a filter. And then they work on the comment that AI filtered, and it requires some level of trust of like the AI as a whole. But since you have this behavioral observing step, and hopefully that can help AI use help humans use AI in a productive way.
Sure. Yeah, I think a lot of what you're saying resonates with some of the work we're doing right now. I just wonder again though about the layer of the user expertise that might play a role in shaping all of this, because of course the tasks you've showcased over here, right? Everything you're saying fits like a glove. I completely resonate with most of what you're saying, but I can imagine that in contexts where you're dealing with lay people who don't necessarily have a very well informed pattern of reliance, the way trust would probably manifest and form in those interactions would probably be a little different. And I'd imagine whether you've come across these thoughts and whether you've explored in your own work how that can play a role, right? So when we say reliance on an AI system in the decision-making process, of course, everyone's probably also using different ways to measure trust, right? That's the other big issue. I'm curious about your thoughts on that front.
Yeah, I think that's a very good point. Actually, it's useful to kind of explain that like all the experiments that I presented here are with crowd workers. So they are kind of, I don't know, generally you assume that they are lay people. And I think I totally agree. I think a big issue in this is like there can be a lot of differences between individuals, and a lot of the experiments that we have been doing, or like a lot of the related research I've been doing, are with crowd workers because of its convenience. But that also means that you may not be actually capturing like the right audience or the operator audience for some of these decisions. And I think like a very important kind of problem, maybe that's useful for, like, first I would like to just end there and say that there can be very big individual differences, and lay people and experts can be very different in a lot of ways that they behave. And I think that's an important problem to work on. But second, I think I want to kind of highlight this recent line of work both in our group and other group, like on this issue of like onboarding with AI, and I think that can be very important and interesting, and then maybe able to kind of align people's mental models a little bit to make sure that they understand the AI a little better. Like for instance, in some of our work like this can be manifested as a sequence of examples, and people can look at these examples and know how AI behaves, and that gives you some like at least get everyone on the same page. Not exactly on the same page, of course, because everyone will think differently, but still they have this minimal training component that gets them better situated in the context of AI, or this particular model when I say AI. Yeah.
Sure.
Thanks.
Yeah.
Yeah, those
Makes
are very
sense.
good questions, and I think let's chat more afterwards.
Sure. Thanks a lot for your answer. I do see that we have another question here from Shran Biswas. Shran, would you like to unmute yourself and ask it?
Yeah, thank you for the talk. So I was wondering, for your second task, you had this task of toxicity defining. So I was wondering, how do you place controls in your crowd computing task, for example? So do you define toxicity, or do you create a training environment for people to see what their definitions of toxicity might be? Because I might assume that the lot of human biases about what is toxic can spew into your task as well. So I was wondering what kind of controls you had in place for this kind of.
That's a very good question. I think we didn't try to define toxicity, like as you said. I think like this is a problem a lot of people are working on, and I think it's hard to define it precisely. But we do give them like 4 questions, asking them to evaluate whether those 4 are toxic or not. And we like 2 are very obviously toxic and 2 are very like non-toxic, but that can helpfully kind of align them with the notion of toxicity. But I think the important thing is that's useful to know. Like I think is like in the end, I think all humans are kind of facing the same definition in the end. And it seems that at least like for if anything that AI is doing, like in a way, like I think by playing with this conditional dedication interface, people are able to align their definition with what there in the data set that we used in a way. But I agree. I think toxicity can be like a very difficult problem to work with, and I think that kind of goes back to this notion of working with experts versus lay people. Like initially, I think ideally the outcome would be try to have quickly adaptive classifier to each subreddit, and hopefully we can also recruit moderators to do these tasks. Then like they would have some better defined toxicity, or is the no toxicity that's aligned with their own community.
All right, thank you so much.
Yeah, that's a very good question, and I think there's a lot of work to be done to actually like make this constructive, useful for people.
Thanks, Chenhao. I'm looking around to see if we have more questions here. I see Garrett has one. Yeah, go for it, Garrett.
Yeah, it's on a little bit more of a general take, but at the end of your talk there, you brought up this interesting idea of the human strengths and the AI strengths, particularly opening the question for AI strengths and what are they? I'm wondering what your thoughts are in terms of this idea of explainability for AI models, machine learning models, et cetera, and how that can help us identify those strengths in AI. And kind of an extension of that, because explainability can go for, it's targeted at the model, but it can also be oriented with the designer or with the end user. And so how does that kind of play into that whole idea of finding these AI strengths?
Yeah, totally. I think like your second part of the question was about to be my answer to this. Yeah, I think like for instance, like the second word, conditional dedication, is one example to kind of identify AI strengths. Like I think in general, AI, like I think like in the end, I think I kind of in this talk in particular, like I have other talks, I'm going to upload my slides to make sure my website is updated. But if you're interested, I think in general, I think like this work particularly highlights one strength of AI, like the ability to dealing with scale. It's very efficient and is it only costs electricity. Okay, that can still be a big problem for some very big models, but in general, it's very efficient and it can deal with scale much better than humans. I think that's one big strength, and I think is useful to think about how to use that strength, especially in high-stakes settings where maybe automation is not the answer, and like full automation is not the answer. Second, I think like AI strength, like a lot of lies in pattern matching, like it's very good at matching some patterns. I'm not sure, like, and I think that like conditional delegation is kind of one way to leverage that strength, where like you allow people to identify like which parts the pattern matching works well, which part doesn't work as well. And I think there can be a lot of work to be done to actually make that process efficient. And as you can tell, like right now, what we have is actually not that scalable. Like in the end, people maybe make like 15 rules at the most, and that's not enough to actually cover the entire space of possible comments. And I think indeed, like for the second part, I think explainability plays a very important role, like for people to decide like whether this pattern matching is actually legit. And I think, as you said, a lot of explainability work is focused on AI these days. And in some like recent kind of preprint world, I think we make this argument like in the end, I think if our goal is to achieve complementary performance or like combine human strength and AI strength, and the important thing is to think about how to design explanations for humans. And it needs to have some component of faithfulness, like maybe similar to the decision-focused summarization work. But it's more important that these explanations actually like tailored to human cognitive ability and make sure like they are aligned with how humans are going to make sense with explanations rather than just being faithful to AI. And I do think like that's another kind of big missing piece in the line of work on explainability. I hope that answers your question.
It did. Thank you very much.
Thanks.
All right. Chenhao did tell me that he had a full hour available for us, and now that we're striking extremely close to it, unless Shreyan, you haven't.
Yeah, I can take one.
Yeah, you can take one more. All right, Shreyan, go for it.
Yes, thank you again. So it's not more of a question, but I remember in your first task, you had the text summarization with food reviews. I was wondering, I wanted to hear your opinion about introducing multimodality. For example, I know that seeing a picture of a food might result in better performance about guessing the review and even to some extent summarization. So I was wondering if you had considered this kind of multimodal introduction in your work, especially with human aspect involved.
Yeah, that's a very, very good point. I think in that particular work, we didn't consider multimodal, but I think I do think that is kind of increasing in the future, and we are trying to do more like multimodal work in the medical space recently, but I don't have like concrete projects in that yet.
All right. Thanks.
Cool.
Okay, then with that, let's try and wrap this up with a warm round of applause. Unfortunately, we'll have to do this in a virtual capacity with visual reactions, but Chenhao, thanks a lot for taking time off. I appreciate it.
Thank you so much for having me. This was quite nice.
Awesome. It was an interesting talk and great discussion as well. It was a pleasure having you. Thanks everyone for joining. Let me just quickly remind you all that we won't have a talk in this series on next Monday, but we will have one on the last Monday this week. We'll have Jiho Kim with us. But yeah, do tune in. And Chenhao, thanks once again. It was lovely having you here.
Thank you so much. Bye.
Take care, everyone. Bye-bye. This is the Academic Fringe Festival. People keep coming back. See you next time.